A couple is a system of forces whose resultant is zero, but whose resultant moment about a point is not zero. A couple is made up of two forces that are equal in magnitude, non-collinear, parallel, and opposite in sense. So the sum of the moments, it's the sum of the moments of the pair of these forces. So if we had, in three-dimensional space, this is my point zero. If I were to draw two forces that make up a couple, they would be in the same plane, but not necessarily, but they can't be collinear like all what we've been doing so far. But they're equal in magnitude, but opposite in sense. This is what it would look like. So I have F1 and F2, but I have that the magnitude of F1 is equal to the magnitude of F2. So we can just call this F. These two are separated by a distance d. So the moment, I could define a point on F1 and call it A. I could also have a point on F2 and call it B. I could define the moment about A, just looking at the magnitude of that moment. If I'm looking at point A, the magnitude of the moment about that point would be the force F2 times the perpendicular distance to that point, which would be D. Or I could define the moment of this system as the moment, or I could say use point B, and I have the moment, or the force 1 in the perpendicular distance D that's causing that moment. So, since I have this relationship, then really my moment A, the magnitude of my moment, is equal to my magnitude of B, which is equal to the force times the perpendicular distance between the two forces. So the magnitude of a couple moment about any point in the plane of those forces is equal to the force, the magnitude of the force, times the perpendicular distance between the forces. So let's look at this mathematically. Looking at the same system, if I were to take the moment about point 0, I would need to define R to some point on F1, so I could draw an R to point A, and we'll call that R1. I could also do it to point 2, because I have two forces acting on this system about point 0. So that's R2. So I have R1 and R2. I could also say that RAB is here. So if I were to find the moment about point 0, not the magnitude, just the regular moment, I would need to do R1 cross F1 plus R2 cross F2. I need to sum the two moments that I get, the one from each of the forces. Well, since I know that F2 is equal to negative F1, because now I'm using vectors, the magnitude or the direction sign does matter, then I can rewrite the moment vector as R1 cross F1 plus R2 cross negative F1. just substituting that in there. Well, I can rearrange, and then I can take R1 minus R2 cross F1, and then that's equal to RAB cross F1. So if you do your vector math, the vector R1 minus the vector R2 is equal to RAB. So now I can define my moment of my system about point 0 as RAB cross F1. Where RAB can be defined as the vector between any 2 points on F1 and F2. What are the characteristics of a couple? Well, just think of them as a moment. They're going to have a magnitude, a direction of rotation, and an orientation. So they're going to rotate about some axis. So that axis is going to be normal to the plane of the couple. So you're going to have the right-hand rule. You're going to have your R cross F, and it's going to have an axis that comes out, and it's going to be rotating around that axis, just like any other moment. So you can think of them that way. This is a conceptual example talking about how, if you want to think about couples, if you're holding onto a steering wheel, you apply a force downward in this direction and upward in this direction to turn that wheel around this central axis. So you're creating rotation about the axis that is perpendicular to the plane of these two forces. Couples can also be transformed. So without changing the external effects of a couple on the rigid body, you can translate it to a parallel position in the plane or any parallel plane. You can rotate it in its plane, and you can also have it so that the magnitude of the two forces, or D, can change as long as F times D stays the same. Note that couple moments are vectors and they obey the same laws of vector addition. So what are these? So first of all, if we talk about translating to a parallel position in its plane or any parallel plane, what does that look like? If you have a member, looks like this. This is a wall, it's attached to a wall. It's attached here too. If I have two forces being applied as a couple, so they're equal in magnitude, opposite in direction, they have some distance d between them. I can change that up and move those forces over here, that couple of forces. So I'm just translating it on that body to a different place, and it's the same thing. I get the same magnitude, I get the same couple. So number 2, I can rotate it in its plane. If I look at this same one here, and I rotate it in its plane, I can have a force like this with the same distance, and this is the same couple as this couple. And then finally, I could also translate that same, transform that same thing by make my force half, for example, my two forces half, which would mean then my distance would need to be double for that to have that same magnitude. So these are the 3 major transformations that you can do. Couples are represented as moments, so the way it's going to look when you represent it. So if you were to change the pairing of forces that you have creating a couple and representing it as a moment, you would just change it to look like this and represent it with the magnitude m. So that's how you would draw it on your diagram.